technical talk of the night because we are kind of simple users of AI, but certainly in production. Yeah, I work at a place called Val.town, and we've been building a code writing robot called Townie. And it's really our first time running LLMs in production, probably like most companies, because they didn't exist recently. Val.town is mostly a platform for serverless computing, where you can write small snippets of TypeScript, and they run with zero configuration and instant deploys and community features. But AI is kind of like one feature within that, because despite a lot of people liking to write little amounts of code, some people like to write none at all. So Townie is this UI within our UI. It's a chat app where the chatbot writes TypeScript and then instantly deploys it like the rest of the application. And you can kind of have like a long, well, it's a confusing example because I asked it to build a chat app, but you can have like a long conversation and ask it to modify that code, and then you can switch to the code tab and collaborate with the computer, etc. In broad strokes, it's kind of similar to Anthropic artifacts or V0. But the biggest difference is that like we're deploying the code as you're writing it. So yeah, kind of in contrast to the cutting edge stuff, we use Anthropic and OpenAI. The meat and potatoes are, running TypeScript in production on multiple servers and making sure that people can't hack each other, that kind of fun stuff. So we're really riding on their coattails. But even though we're taking the easy path, LMs are chaotic. So basically they're magic, but they're expensive, unreliable, unpredictable, and slow. And yeah, I'll just go through each of these in order. All right, first of all, smart models are expensive. Like a lot of the companies, I think there's this old Henry George graphic of like, jobs giving people money and then people giving their landlords money. We're trying not to do that business model, we're trying to have a normal amount of spend, and interest rates are non-zero. So the main trick, I'll go through a few tricks. The first trick is just like using different models for different tasks. We use 3 models, sometimes 4, depending on things. So for example, we'll use Sonnet to actually generate the code, which we really need the intelligence. Sonnet is the only model that can really tell that it's running code in TypeScript for Dino and doesn't get confused and accidentally write code that runs in a browser or for Node.js or just switch languages entirely. So we need that intelligence. But then when we take that code, we have to like give that code a name. So we send that to V0, which is magnitudes cheaper. And then when we evaluate those results, we send that to V0 Mini, which is even cheaper than that and even dumber, but it doesn't really matter. So the learning here is just use an abstraction library. Maybe it's obvious advice. And I know that there are thousands of these, but Vercel AI is what we've been using. We didn't evaluate the thousands of alternatives. It works fine. And we have to do this because like the fastest model just changes every couple weeks. The other thing is that we're doing a chat interface, and like at least I didn't realize it at first, is that AIs don't have memory. So when you're having a long chat conversation with them, the naive approach at least is that you're sending the entire context to the AI for every message. And so every message gets slower, and also the models get worse every time that you make the conversation slower or ever longer. So our main approach is just to solve this with UI. We just tell you that Townie is going to get dumber if you keep typing, and also it's more expensive for us. This seems like kind of naive UI, I guess, but it's also the UI that the real big players use. So it works. But the much cooler solution is that we heavily use prompt caching. So that's for Anthropic. I'm not even sure if OpenAI supports it. Maybe, probably does. It reduces the cost of like reprocessing those tokens. So you can put more of the conversation that's already been written into the model. and you kind of have like this boundary between what's the new content and what's the cached content. Caching costs more money, but then reading from the cache costs a lot less money. The economics are pretty good. So yeah, here's essentially like after we turned it on. We have at the top when we're reading from the cache. Here we're writing from the cache, and then the bottom is the expensive tokens, the actual tokens that we're spending, and the model is processing for the very first time. And I mean, separate from all the LLM stuff, I think this is kind of a cool graph because if you like zoom in and color it by which thread people are talking about, you can see these little arcs of when a certain long conversation is happening. And we have these cache reads of like increasingly long threads. And you know, these would be our most expensive requests. So those are things that worked. Here are some things that didn't work. One of the, so the conversation's really long, and let's say that you like write something that is 2,000 lines of code. It's really tempting to say like, oh, truncate your old messages. One thing that we found is that if we truncate messages, then the AI will truncate messages back to us. I feel like a lot of these things are kind of like when you have a young child and you tell them not to do something, but they hadn't thought of doing that thing before you told them not to do it, and then they do it. The other thing that AI is really, it's been a challenge is to do diffs, to do unified diffs. They'll give you things that look like unified diffs, but all of the numbers are wrong. And it will just omit stuff in the original document. There are at least 3 or 4 projects that are all trying to solve this, and we've essentially given up on it because you know it's easier to just send the whole thing back. Reliability, the lack thereof. All right, so Anthropic is at two nines so far, not great. OpenAI, two nines. So yeah, you'll have downtime if you rely on mainstream API providers. We've had downtime. It's kind of unavoidable because unfortunately, if you look at these two graphs, there's also like a lot of overlap in the time that they had downtime. Yeah, not great. So what we found is that people just socially expect downtime out of AI apps. They expect them to be kind of imperfect. And a lot of people are also using like 2 other apps that are using Claude, and they know that Claude is down. So we just communicate that, and it's been fine. But it's also kind of shocking, I don't know, from like a previous experience with engineering level to have such a low number of nines. And then unpredictable. So essentially, a lot of the things that we thought would improve prompts make prompts a lot worse. And so we've implemented evals. Here are some of our evals. These are for things like calling the alert function, which is really annoying, or just omitting all of the code. And yeah, so this is another thing which is a real departure from how previous engineering efforts worked. Braintrust creates these beautiful charts for us, as well as these reports on pull requests. But there's a ton of jitter in these reports. I think that an interesting thing here is that like these are per run. For most of these, we haven't changed anything. It's just statistical jitter. It's just like temperature. So it just kind of, it's all random from now on. Here's an example of like one specific example where we're running all of these scores. We're trying to figure out whether it just decided not to give us code. And there's this unnerving kind of epistemological breakdown, which I think about all the time, which is that a lot of these scores are themselves based on AI models. So I mean, you probably need a human in the loop at some point. Otherwise, you're just going to create results that AI thinks is good. And that will perpetuate a lot of the things where it has existing misunderstandings. The whole exercise of trying to improve this reminds me of this lovely E.L. Doctorow quote about writing a novel where it's like driving a car at night and you can only see as far as your headlights, but you can make the whole trip that way. I think like every one of our small improvements has been based on extremely limited incremental knowledge. And we just are hoping that, at the end of the road, there's something. Okay, so slow. I mean, it's getting faster, but I think there has to be some recognition that like when you get a text message from a friend, it doesn't stream into your phone. And the same for most digital experiences. It would stream into your phone if 5G connections were a lot slower, but they aren't. So essentially, we're left with the problem of implementing streaming, but trying not to get nerd sniped into turning our entire application into like a WebSocket real-time experience, which would be cool, and we would use JamSocket, and we'll do it eventually after the Series A. But for now, we keep it super simple and server-side events and this beautiful TRPC method called unstable HTTP stream batch stream link is what we do. Because otherwise, there's this principle in which like you have your you have the graph of all the requests to your server, and all the requests are like 100 milliseconds, 50 milliseconds, 300 milliseconds, and then there's one that's like 30 minutes, and that's like an AI-based conversation. It kind of like breaks all of our assumptions about observability and how we're building applications. And we'll break those eventually, but not now. So yeah, that's it. Thank you.